Switching is the process of moving a packet from an ingress interface to the egress interface so it can be sent on its way. There are 3 different ways we can accomplish this on our Cisco Catalyst switches. The first one is process switching, the oldest and slowest method that is available. Slowest. Does that mean you want to use it? Probably not. But why is it the slowest? It's the slowest because every single packet is examined by the CPU. So as a packet arrives inbound on an ingress interface, it has to be sent up to the control plane. And then the control plane examines that. So the RAM is getting involved, the processor on the device is getting involved, making it a rather inefficient process. However, the IP routing table is checked, the ARP cache is then checked for the MAC address of the next hop IP address, and then out the packet goes through the egress interface. And this is going to happen for every single packet. So every packet is going to have the decision made in software, which is a really, really slow process. Let's take a trip together. We are driving along the highway and we are lost. That's right, we are lost. So we stop to ask directions from a local gas station attendant. How do we get to this particular destination? They open a book, they review the information in the book, and they say to get to this particular destination, go that way, turn left, do this, do that, whatever. Okay, fine. They close the book, they put it aside. We go on our merry way. 3 minutes later, somebody stops and says, how do I get to this destination? And it just happens to be the same destination that we went to and we asked about. They grab the book, they open it up, they find the page, they read it, they provide that family with the information about where to go. Minute later, another family shows up asking the same question for the same destination. Out comes the book. You see how inefficient this process is? For the exact same destination that's being asked about. We keep having to reference that book. We keep having to reference the control plane, or the gas station attendant has to keep referencing that control plane, that book. So how can they become quicker? How can they become more efficient? Well, what if they memorized the information that was in that book once they looked it up the first time? We asked for directions, they looked it up in the book, they cache that in their memory. They store that information. Another family shows up asking for the same directions. Do they have to look at the book anymore? No, they don't. It's in their memory. Well, this is what we're dealing with fast switching. It's a faster method than process switching because a route cache is created. And we can see the route cache right down here. There it is. Where is that route cache? It's at the data plane. So the book at the control plane does not have to be referenced by the gas station attendant anymore, making it much faster. But here's what we have to realize. The first packet or the first request made by somebody for a particular destination has to be process switched. Going back to that relatively slow method. So when we examine that packet that arrives, ingress on an interface, and it comes up, the data plane, it has to go to the control plane so the control plane can examine the information. So this is the control plane here, and this is the data plane over here. So we're still bugging the control plane. The gas station attendant is still referencing the book for the very first packet. After that, an entry is made in the ARP cache, not the ARP cache, in the route cache down at the data plane. And the packet is sent on its way. Now, the rest of the packets that belong to the same flow. What is a flow? A grouping of packets all coming from the same source, going to the same destination, using the same protocols, using the same port numbers, arriving on the same ingress interface. Wow. A lot of values have to be the exact same to be part of the same flow. Well, they are part of the same flow, meaning they can use the same entry in the route cache. Therefore, every other packet that arrives that's part of the same flow, simply is switched based on the information in the route cache. We no longer have to access the route processor. So there's that analogy whereby the gas station attendant has memorized the information based on the first lookup or the first request, and after that, it's already in their memory. They just recall that information from their route cache, from their memory. It's a much faster, more efficient process, but the problem we run into is that if our environment has a large number of flows, different flows, meaning packets coming from different sources, going to different destinations, using different protocols, different port numbers, then the very first packet for all these flows has to go through the control plane. It has to be examined by the control plane first, and then put into the route cache and then forwarded, slowing down the overall process. There has to be a quicker way, and that quicker way would be Cisco Express forwarding.